Hello everyone and welcome back to the channel. Today I'm excited to share my complete process for editing images of Jupiter. We'll start with the raw video captures of the planet and work through each step until we achieve the final image that you see here on the screen. I know this video is a bit long, so I've added timestamps in the description to help you jump directly to a specific part of the process. Whether you're following along or just curious, I hope this tutorial gives you the tools and confidence to process your own planetary images. So let's dive in, guys. First, let's look at the original data and go over the equipment I used for capturing it. So here I have a folder filled with the different videos of Jupiter from October 29, 2024. I captured these videos using my 10-inch Schmidt-Cassegrain telescope at its native 2500mm focal length, along with the ZWO size 715 MC camera, which has a really tiny 1.45 micrometer pixel size that is perfect for capturing a detailed image scale without needing a barrel lens. For this particular night, I did not use an atmospheric dispersion corrector, though the results might have been even better with this one. So everything was mounted on a Skywatcher EQ6R Pro mount that holds the 10-inch telescope pretty well. When capturing images of Jupiter, I set up guiding, so basically my planet keeps centered at all time of imaging. As you can see, this is an example of one of my 1-minute videos. So Jupiter stays centered, like if we go at different times for the video, Jupiter is always centered. And here I got, I think 31 different videos of Jupiter. I was taking it from, this time is in UTS, 6:12 in the morning up until 6:43. This period of time, I was capturing Jupiter longer on that night, but basically this 31 minute I had the best seeing conditions for the whole night, and these videos we're going to process in this video tutorial, guys. So as you can see, all these videos are saved in .ser format, which is ideal for planetary imaging because it preserves high quality frames. In other words, we're capturing raw images. And if you're interested in learning more about the .ser format or other tips for planetary imaging, just check out my video called 15 Tips for Planetary Imaging, where I cover this tip and other useful techniques that you might want to use when taking your images of planets. So with all this data that we got, 31 different video files, we'll process them into a final high-quality image of Jupiter. Well, when I say high quality, it's going to be the best one. I think that's the best one that I've ever taken, and particularly for this night, yeah, it's going to be a good result. So now let's talk about a software that I'll be using today. So on the screen, I got here 4 icons with the different applications that we'll be using tonight, and let's briefly go over each of them. So basically we got here Autostakkert app, Registax 6, WinJupos, and Adobe Photoshop. So Autostakkert app aligns and stacks frames from each video and creates a single, more cleaner image of Jupiter. And when we stack images, we basically reduce noise and improve image quality by analyzing all the frames that were taken during the video and combining only the best videos that we're capturing during the imaging session. Second app called Registax 6, and this is where I will apply sharpening to my images that I receive from Autostakkert. The sharpening goes through applying wavelets, and they bring out fine details in Jupiter atmosphere, in particular the Jupiter's cloud bands and other features that will give the image a bit crisper look. The next application we got is called WinJupos, and it's really important for planetary imaging. And this one is used for derotation, which is pretty much crucial for Jupiter imaging since the Jupiter rotates quickly. The period of rotation of Jupiter is a bit less than 10 hours. And pretty much if you, let's say, take images of Jupiter at a position, potentially you can take an animation of the whole day on Jupiter if you capture it during the whole imaging session, of course considering that you have good seeing conditions. Anyway, the rotation of images will align them so that features like different cloud bands or great red spot or different features in the atmosphere of Jupiter, they will become even crisper and more prominent. So yeah, WinJupos brings us lots of details and helps to get even better images of Jupiter. And the last one is Adobe Photoshop. So pretty much in Photoshop, I will perform their final post-processing steps that will include color balance, color adjustments, playing with curves, contrast, and different visual elements that will make the final image looking even better. So now, since you know all the tools, let's go to my step-by-step plan that I'll be following to process the data. The first step is taking in Autostakkert, and here I'll start by batch processing all these videos in Autostakkert to create individual stacked images. The second one is applying wavelets. So basically I'll apply wavelet sharpening to each stacked image in Registax, and that will bring me more details. The next step will be taking a look at these images that I got out of the Registax and selecting the best images. So pretty much once wavelets applied, I will review the images to identify the best ones with the best quality based on the details and clarity. And what I'm going to do then, I will reapply wavelets to the best image. So when you do apply wavelets and apply sharpening, sometimes you think you do a good job basically applying wavelets, but sometimes you can either oversharp or undersharp images of Jupiter. So by looking at these images of Jupiter that I will already have out of the Registax, I'll define which one is the best in my opinion. Then I will go back to my stacked images in Autostakkert and I will reapply wavelets again to my best image, and we'll see if the details look a bit differently. If they will, and most likely they will, I'm going to batch process my images of Jupiter again with a new wavelet settings. So pretty much by doing this process, I hope that I will improve the sharpening on the Jupiter by providing a bit better result, and eventually, it also will affect my final image. So after I basically reapply the wavelets in Registax, what I'm going to do, I will go over these images again and filter the top images. So by this I mean that I'm going to pick the top quality images out of the one that I got from the Registax, and the best out of the best images I will be using for derotation. And the next step, of course, will be derotating images in WinJupos. After I get my image from WinJupos, I will apply final wavelet adjustments in Registax. Those will be really minor adjustments to make an image a bit sharper. And when I have this image, I will finally go to Adobe Photoshop, where I will do my final post-processing stage. Alright guys, so let's pretty much begin our processing. So we're gonna highlight all the .ser files, video files. We're gonna drag them and drop in Autostakkert app. Alright, I want to make sure that my planet icon is here, it's checked, and I will start analyzing images. So this action will determine which subframes have better quality, which subframes have a bit worse quality, and here I have quality graph with my best subframes and my worst subframes. Now that really depends on how many frames I have in each video. Pretty much I stack somewhere between 20 or 25% of my frames into the stacked image. So for this one I also can do it a bit more, I believe, but yeah, let's do 25%. That will be approximately 750 frames in each stacked image. Let's keep it that way. Now, since I didn't use atmospheric dispersion corrector, I want to make sure that RGB align icon is active. Yeah, I will be saving my subframes in a separate folder. These two parts I will leave the same. I'm not going to use a drizzle. This image has pretty good scale already. On its own, drizzle is not an option for now. Now let's pick our alignment points. So there are a couple of ways you can do that. You can either do it automatically, and basically pretty much alignment points, they all aligned automatically with a different scale. For this video demonstration, I'm going to leave it the way as it is, but pretty much sometimes what I do is to set my alignment points manually. I kind of do it this way, all the way around the Jupiter's edge, like so. Then I go through cloud bands of Jupiter over here, cloud bands here. Then I got this one. There are some parts of Jupiter here. Then I might go with a bigger one, but anyway, for the demonstration video, let's just use automatic alignment points, like so. And as you can see, since we dragged all these 31 videos in Autostakkert, they automatically, all of them, they will be added and used over here. So since we picked all the alignment points, we're gonna stack 25% out of almost 3000 frames. Let's just hit stack, and the stacking process begins. So as you can see, this process goes pretty much as kind of batch processing. All these images, they being analyzed, aligned, and stacked automatically. So all we do at the moment is just waiting until all these 31 images will be processed. So what I'm going to do now is to pause the video up until the moment where we have all these 31 video files processed. Alright, so the batch processing is completed, and let's look at our folder with video images of Jupiter. So as you can see, we got a new folder called ASP25, which basically means Autostakkert %25, and here we got all the individual stacked images of Jupiter. So as you can see, there are 31 frames, and let's close Autostakkert now and open Registax. So what I'm going to do now is to open just like a random image of Jupiter. Let it be, I don't know, this one. Let's just drag it to Registax. So image seems to be in color, processing color, of course, yes. Alright, and here we got the following. So as I said, in Registax we'll be doing a sharpening of image of Jupiter, and also we're gonna do color calibration, like first color calibration here. So the first step is applying wavelets, and there are different like wavelet scheme and filters that we can use, and I know some photographers, they use different filters. What I use for my images of Jupiter is I use linear wavelet scheme, and I use default filter. The step increasement I set to 1, so that basically all the steps that here they apply wavelets a bit stronger than usual. And here we have 6 different sliders that apply wavelets, or in other words, apply sharpening based on the size of details that we have here. So as you can see, we can preview, like by holding these buttons, we can preview the size of details that will be adjusted on each scale. And pretty much what we can start with is just randomly applying like this slider 2 or 3 wavelets, just to see what's gonna happen. And yep, as you can see, I kind of picked already a nice subframe with some nice details on Jupiter. So the idea is that if we bring up this slider, the first one, to the right, what we're gonna have is pretty much just noise on the image. Yes, we have some sharpness in smaller details, but we also get lots of noise over here. In the meanwhile, if we adjust like slider number 6, then it's not doing anything good, and yeah, we just ruined the image. So pretty much by like applying the wavelets, you just gotta find a taste how you want your image of Jupiter to look like. And what I'm going to do, yeah, because for example, you see if I adjust this slider, the smaller, like the final details, they appear much better. So yeah, what I'm going to do is to adjust this slider like so. Alright, then I will adjust this one a bit. Yeah, like that. I don't know if I want to do anything with the first one. And by the way, if like you slide it like this and you want the slider to go back, you can right click and it's all gonna go back to default. So I mean, I might leave it like this and we'll see how it's gonna go. Let's see what's gonna happen if I adjust this one. Yeah, nothing good. And this one, of course, nothing good. But sometimes with the higher scale details on Jupyter, better if we drag like this higher scale details not towards the right but towards the left. It makes the image looking just slightly softer. All right. Yep, like so. And this one. All right. So I kind of like how the image looks at the moment, and I'm gonna keep the settings the way as it is. And also what I'm going to do is adjust the color balance. For that we need to open color balance, and what I'm doing is just hit auto balance for now to balance the colors on the image. And that's pretty much it for this stage. So what we're going to do, we need somehow to do batch processing. So for example, if you click do all and you save the image, you can pretty much save just one image, but we have like 31 individual picture of Jupyter that needs to be stacked, and luckily Registax allows you to do batch processing, and I'm going to show you how to do that in a second. So first of all, we need to save the current scheme for our wavelets. For that we hit save, and as you can see I have lots of different variations already saved. So I'm gonna call this one Jupyter, and usually I put a date when I process my images. For a moment it's November 15th 2024, and let's call it version 1 because maybe, as I said later, I will reapply my wavelets and do them slightly better. So yeah, anyway, we're gonna hit save, and I don't know like why Registax on my computer works like that, but in order to do batch processing I need to close Registax. I'm not gonna save anything. Now I'm going to open it again, then I will randomly drag like just any image of Jupyter. Now we're going to hit auto balance. We're gonna load the scheme, which is the one Jupyter 11. This one. Open. And we're doing this. So we're going to tools and this button called show macro/batch window. Now we need to pretty much this window is for the batch processing in Registax. So here pretty much we need to automatically color balance each image. Then we need to apply wavelets that we just loaded here. We're gonna apply them to all individual images, and the final step is save the image. I'm gonna use TIFF format over here. And since I already told you guys I'm going to revise my older stacked images with applied wavelets, so I don't want to touch my original stacked images. I'm gonna highlight them all, copy, and let's create a new folder called Registax version 1. All right. So now we need to add files that we're gonna batch process, and this part is actually a bit tricky. So what we're going to do is to locate our folder, which is on the desktop. I got this folder, Jupyter. Here is the folder called Registax 6 version 1, and as you can see, automatically you can only pick the following video files. right? So what we need to do in order to get our TIFF files, we need to go to file name and do the following. So star dot star, hit enter, and as you can see now we have all their pictures in this folder shown. So we're gonna highlight them all, hit open, and pretty much, let me just resize the window so that you're gonna see what's gonna happen. So we have all the files, we're gonna color balance them all, we'll apply wavelets, and we're gonna save them as processed images. So go hit run, and all the 31 images, oh, Registax just changed it. Anyway, all the 31 images, they automatically processed by Registax, and all you have to do is just wait, guys. And I think I'm gonna put this part like on a time-lapse mode because it's nice to see how all these images, they just change. Alright, batch processing is completed. What I'm going to do now is to close Registax. Alright, so let's go to the folder, and we finally can take a look at our stacked images with applied wavelets. So here is the image, and we can just quickly look at them. As you can see, first of all, we can already do a short animation of Jupiter's rotation, and as you can see, as I go through the frames, some of them have a bit better quality, some of them have a bit worse quality, in particular these parts. Like here, they're more obvious, over here they're a bit blurred, and I think I've already mentioned it a couple of times in the video, but guys, please put this video on the highest resolution possible, because YouTube compresses the video files, and if you're watching this video at the original resolution, you're gonna see like all these differences, all these crucial differences on the screen. So for example, see this image is a bit blurred, this image is good, and what we're going to do now is to determine which image is kind of the best out of the best, I think. And it's really hard, but I think this one. So it's 626. So let's just briefly look at different images. Actually, yeah, this one. So if you look at this part of the Jupiter, like here, 626 is more blurred, while here it's more obvious. So actually 624, 623, they look good. And 621. Okay, let's delete 622 and compare 621 and 623, and they pretty much look the same. So yeah, as you can see, at this step of processing is just basically blinking images and looking at their differences. So yeah, I believe 621 is better. In this part, 623, these details in Jupiter's band, atmospheric band, they're more blurred compared to this one. I don't know if you guys can see this, but I definitely see that, yep, 621 is better. And when I say 625, and when I say 621, I'm referring to basically the time when image was taken, and that's how I'm going to determine which image I will be reprocessing again in Registax. So yeah, I think I'm gonna go with a 621. So, as you can see, we determined that image, this one, 621, looks like it's the best out of all these images. And what I'm going to do now is to open my folder with all the stacked images of Jupiter without applied wavelets. And guess what? We're opening Registax. And then we pick this image, 621, we go to Registax, and I'm gonna repeat the process again. So we'll do color balance. I'm going to load the scheme that I already used, which is this one. Alright, and I just want to kind of play with wavelets again to see if I can do any adjustments to make this image even better. So I think it's gonna take some time, but yeah, let me just look into this. Alright, so I think I'm gonna go with this option. So I kind of like how this version of the image looks like. These wavelets, they slightly, like, before doing WinJupos, you wanna apply wavelets, you wanna make your image sharp, but you wanna still keep it soft, because we're gonna apply wavelets again to our derotated image a bit later, so the image will become a bit sharper later on. But yep, you don't want to do image too sharp at this stage, otherwise they will be really over sharped on your future stage in processing of images of Jupyter. So yeah, you kind of want to keep it that way, and I'm going to save this scheme and I'm going to call it same Jupyter 11.15, but it's going to be version 2. Alright, save. So doing this again, closing Registax, reopening it, just dragging a random image. Alright, RGB balance, auto balance, say, hold on, not save, load scheme, Jupyter 11.15 version 2. Alright, open. Now we're going to tools, batch window, so functions, RGB balance, wavelets, BAM, wavelets save, TIFF. Now we're going to add files, and by the way, I forgot to create the folder. So we're gonna copy these files from original stacked folder and create a new one called Registax 6 version 2, because we're gonna apply wavelets to these images. So once again, the reason I'm doing this, I'm kind of sure that I'm not gonna touch my original stacked images, but still, in order to keep them untouched, I prefer to copy my stacked images to a different folder and work with them. In case I want to go back to the previous stage, I can do it easily by just going back to the folder and making a copy again. So let's locate this folder, add files, desktop. Alright, doing this again, star, pick all the images and hit run. Alright, so the batch processing is completed. Let's close Registax now and open the folder with our second version of stacked images. So let's quickly review what we've done so far. So we stacked images in Autostakkert, we applied wavelets to them, then we checked and determined which images look better. I got the best one, which was this image with a 621 timestamp. Then I reapplied wavelets to this image, and I did batch processing again with my different versions of these images right here. Now what we have to do is to basically filter out these images and pick once again the best out of the best images that we will be derotating in WinJupos. So what I'm doing here is I'm gonna copy these images, create a new folder called WJ WinJupos, and pretty much here in this folder I'm going to delete all the images that look blurry to me. So for example, this image is definitely blurry, and although this, I mean, I've applied wavelets to this image, it still doesn't look as sharp as, for example, say this image, just because the atmosphere was unstable at some periods of time. So yep, the purpose of this step is to filter out all the bad images and keep only sharpest images possible, because in WinJupos you really want to keep clear image. And for example, if you end up just with like 3 or 4 or 5 images, it's still much better than you derotate and stack all the 30 images without details that are blurred, and it's not going to give you a good result. So yep, I think I'm gonna do this. So basically what you do here, you blink images, and whatever appears to be like blurry, you just delete it. And in order to determine which image kind of looks more blurry or not, you gotta pay attention to these small, like finer details in Jupiter atmosphere. So for example, let me just show it to you. Yeah, like this image. Once again, put this video on a high quality mode. So these details over here, they are prominent, but if I look at this image, they're prominent but more blurred. So we want to get rid of this image. Same like as this one, we want to get rid of this one. And yeah, I think the rest part of the video I'm going to put on a time-lapse mode. Alright, so I think I ended up with 10 images of Jupiter that look the best to me. And yeah, they pretty much, as I blink them, they all look with the same quality. Although yeah, this image is more blurred. Let's delete this one. And this image is blurred. Alright, yeah, so I only have 8 images that I'm going to derotate in WinJupos. So let's open up this software. Oops. Alright, so in WinJupos we gotta make sure that Jupiter is selected as our body, and first step in WinJupos is basically we're gonna open each image and we gotta do measurements. So basically what WinJupos does, it aligns and derotates planetary images, compensating for the rapid rotation of planets like Jupiter in our case, and it pretty much helps during extended imaging sessions. So for example, if you look, like even here, we have image taken at 6:15 and at 6:17, and if we look at both of them, you already see that they both have different rotation of Jupiter. For just 2 minutes, Jupiter rotated quickly, and if we just align these images the way as it is, we're gonna get a blurred result. So, since WinJupos calculates and analyzes all the timestamps, what it basically does, it projects the image of Jupiter taken at a particular time on a sphere, and then it does a projection of all these 8 frames on the sphere, and we'll do the alignment based on the rotation that Jupiter had at the time of imaging. So as a result, we're gonna get a sharper image. And let's gonna do this. So first step, we gotta record our images, and for that we're going to recording image measurement. So the process looks like this. We need to open the image first, and here I'll be pretty much using the hotkeys. So we gotta hit F7 in order to open the image. Now we gotta locate our image. We're going to desktop, Jupiter, Registax, WinJupos. We're gonna open the first image, and how it looks here, it's basically, there are 2 ways what we need to do. So as you can see, here is the circle of the Jupiter, and what we need to do is to align this shape to our planet. So we need to go to adjustment, and by hitting the arrow keys we can do that. If needed, we can rotate the image. We can rotate this shape. But luckily for Jupiter, there is much easier way how you can align this shape to image of the planet. All you need to do, and it works just for Jupiter in WinJupos, is to hit the key on your keyboard called F11. Once we do that, as you can see, this shape automatically aligned to the image of the Jupiter. And the important part in WinJupos is that you gotta have your date and time recorded properly. And as you can see, I didn't touch anything, but these parameters, they're already saved automatically. That's because the naming of my file already contains all information and Jupiter understands it. So it kind of saves my time. Now, talking about geographical position, honestly, I do not change these settings and I leave them the way as it is. Let me know in the comment section below if there are any guys that process images of Jupiter and WinJupos, if it matters or no. In my case, it doesn't matter that much, and I still get nice images of Jupiter. But yeah, let me know in the comment section below if it's really crucial or no. Anyway, so how the process looks: we open the image, we hit F11 key, then we hit F2. Alright, I just realized, so when I hit F2, instead of saving the file, my software that records the screen, F2 is the hotkey to stop recording. Alright, that was funny. Alright, so if I hit F2 now, yeah, alright, WinJupos is gonna save the file. So what we have here, we got two files from WinJupos saved. Let's open the third image, and yeah, once again, you can hit F11 if you want to, but nothing much changes if you use equatorial mount, if you use guiding. For example, if you use a Dobsonian telescope, then you will experience a field rotation, and yep, you pretty much will need to hit F11 in order to realign the shape each time. But yep, for equatorial mount, it is not an issue. Alright, so how it's gonna look like: I'm opening image, saving it, I'm opening it again, I mean the different one, saving it, that was the 5th, 6, save, 7th, and 8. Alright, so we recorded all the images. What we gotta do now is to do basically the rotation. For that, we're going to Tools, the rotation of images, and here I got some previous images, I'm gonna remove them. Alright, so we need to add images. For that, we're going to Desktop, all the way to my files, and here we got all the 8 recordings of Jupiter. Now, you can leave everything the way as it is, but what I prefer to do is to find the most centered time frame images. Let it be this image, right click, and I set this image as a time reference, which means that this image will be kind of a reference for all these images, and all these images will be rotated and aligned based on the position of this image. So I do that. Now you can hit that the north will be at the top. This one I prefer to do a bit wider. Image time will be TIFF, observer. Now this one I'm gonna leave all these settings the way as it is. Let's just do image info, main, let's gonna call it main image. Alright, and also what we're gonna do, I'm finally gonna take a quick look at these 8 images, and I'm gonna pick really the best out of the best. Alright, yeah, I think it actually will be 620. So this image will be main image as a time reference, and this image will be actually a reference image for optimization. So when we hit that, it basically means whatever details we have on this image, WinJupos will be looking for these details in different images and applying them and aligning them with this image. So yep, all the settings are done. All we have to do is just to compile the image. And here we got a derotated image of Jupiter. So we can hit save, but as I'm aware, so this image has got to be saved here already. And yep, we got this TIFF image. If we're gonna open it, This is the rotated image of Jupiter. Let me look at edges. So this right edge, it looks pretty good, but the left one is a bit sharp, and that's due to rotation of Jupiter. So what I'm going to do now is to delete these images over here, this one, this image, and I'm going to delete this image. So what I'm doing is I'm leaving my reference image and I'm saving these two images that pretty much go next to each other on a time frame, and this image I'm gonna call it edges. Compile. And yeah, as you can see, the left edge on this image is slightly softer, so I'm gonna use that later. So basically what we just did, we rotated images in Jupiter, and now let's do final adjustment of wavelets in Registax. I'm gonna open Registax, and let's open our main image, the one that is contains 8 images stacked together. Alright, yep, like that. So let's also pretty much play with wavelets, and actually this one will be more sensitive to applying wavelets. So if we do the second one all the way here, the image will be over sharped. For this stage, we need to apply wavelets to the rotated image like really slightly, and that's what I'm going to do now. Alright, yeah, I think I'm gonna go with this version. So pretty much if I hit do all, yeah, as you can see, this image is much sharper, but still I try to keep this image soft. And now we can compare. If I'm gonna quickly create a folder and just compare these two images. So this image is a result out of WinJupos, and this image is with applied wavelets. So yeah, as you can see, we got some good details here. And what we can do now as a final touch is to actually see how WinJupos affected our image. So this is just a stacked image of Jupiter out of the Autostakkert with applied wavelets, and this one is the result out of the WinJupos. As you can see, the image became, don't pay attention to these different angles of rotation. What's most important, if you're gonna look at this part and this part, they all became more prominent and more obvious, especially these parts over here, and details in atmosphere over here. So yeah, just like stacking these 8 images brought up lots of details in Jupiter, and it's really cool. And also if you look at the noise, this image looks pretty good. It's not Damien Peach level, of course. So yep, let's do our final processing stage in Photoshop. Let's open the Photoshop and drag this image of Jupiter in it. Okay, let me delete the folder. Jupiter, bam. So on this stage, all we have to do is basically I need to work with the color, make the image a bit brighter, and do some final adjustments. Now this stage in Photoshop, I think it's all about matter of taste. Like different people process the image differently. So this part I'm gonna put on time-lapse mode, and I'll see you guys at pretty much my final image of Jupiter. Yep. Alright guys, so I think I finished with my image of Jupiter. This is the final result. This is how image looked like when I got it out of WinJupos and Registax, and that's how the final image looks like. Yep, I think not bad for this quick session. We got some more colors. I think I actually can play with levels a bit more. Like so, I think. Yeah, so it's better to make this image a bit brighter like this. So yeah, this is how final image looks like. Let me just quickly save it. 800 by 100 pixels. All right, let's just quickly check if there are any artifacts that we can get rid of. Oops. All right. Okay, so let's do this. All right, so here's the final image. Let's gonna save it on desktop, Jupiter, October 29, 2024, YouTube, because that's for the video. All right, we got a bunch of files that we don't need. All right, and this is our final image of Jupiter, guys. All right, guys, and there is the end. So we've gone all the way from raw video captures to this final detailed image of Jupiter. I hope that this tutorial gave you a valuable insight into what's involved into planetary image processing and inspires you to try it yourself. To help you practice, I've uploaded some of my raw videos of Jupiter to Google Drive, and you will find the link in the description below. Feel free to experiment, and if you decide to share your results on social media, please credit the source and tag my profile. And of course, guys, I'd love to see your work. If you enjoyed watching this video, don't forget to give it a like, leave a supportive comment in the comment section, and subscribe if you haven't already. If you have any additional questions, drop them in the comment section as well, and I'd be happy to help, guys. Stay tuned for my next video where I'll take you through an actual imaging session with Jupiter, covering the telescope setup, planetary guiding, and the software I use for capturing videos of planets, and in our case it's gonna be Jupiter. So thank you guys so much for watching this video until very end. I'm really hoping to see you at the next one, and until next time, clear skies!